Welcome back, everyone. We are going to see right now just the final few steps for hypothesis testing, and we're going to get started with talking about what it means a test statistic. That's basically going to be either the z-score or else the t-value for whatever statistic we get from our sample. You're going to take a sample from the population for whatever it is, like the mean of something or whatever, and then we will calculate either the z-value if we're talking about proportions, or we'll calculate the t-value if we're talking about means. That's going to be the next step. And then given whatever our level of significance is, we will have, and also, by the way, it depends on whether it's a left tail, right tail, or two-tailed test, we will have what you call the critical region, which, for example, if it's left tail and our significance level is maybe alpha equals 0.05, then we have such a tail on the left side that has an area of 0.05, and we found out that means that it should have a critical value if we're talking about proportions of, for example, z should have been, can you remember what it is? I can hardly remember what it is. It should be this one, negative 1.645, sort of, with some rounding, 1.645. And this is going to be considered the critical region. So if we take a sample and the z-value for our sample is something less than this, and it falls inside of this region over here, then we're going to have a sufficient evidence to reject the null hypothesis, is basically what it comes down to. And then we will have something, it's just going to come from the calculator, which is called the p-value. And that's going to be the probability to get a particular test statistic that we got. And we've found that kind of thing before, which is basically has to do with the area under the curve, to the left of that value, or to the right of the value if it's right tail, and so on and so forth. It will make more sense in the context and whenever we see a problem about it. But we will, based on the p-value, if we consider it to be statistically significant, which is going to be basically if it's a value, if the probability, which is the p-value, that's why it's called p-value, it means probability. If it's less than the level of significance, which the level of significance, by the way, in this case is 5%, and that's something that we've called, if something was less than 5% chance, we called it unlikely, for example. We will use the p-value being less than the level of significance. We will call that a sufficient amount of evidence to reject the null hypothesis. And then once we've done that, once we've either rejected the null hypothesis or we have not rejected the null hypothesis, we will make a conclusion that has to do with some type of careful wording that we saw before when we're making confidence intervals. There's just a certain way that statistics people will phrase things. And so we could see an example of that here. We go through our whole test, we take a sample, we go through all the tests, we use our calculator, so on and so forth, and we will be talking about, in this case, the claim. We're testing this claim whether the proportion of women who smoke is less than 0.35. So the null hypothesis should be that the proportion is equal to 0.35. The alternative, which is what we're testing, is we want to check whether it's less than 0.35. So we're doing here some type of a left tail test, since it says less than. We don't know any other information about the level of significance or anything like that, but clearly we took a sample of women, and based on our sample, we have decided to reject the null hypothesis. So what we will say is there is sufficient evidence to conclude that the proportion, I'll abbreviate, of women who smoke, I wish there was a way to abbreviate that, women who smoke is less than 0.35. That's how that conclusion would go. What about we have such a situation where we're talking about peanuts, and we go and buy a jar of peanuts. It's an 8-ounce jar. we're testing this statement of whether the mean number of peanuts is not 200. So our null hypothesis is that the mean number, which is mu, the null hypothesis is always equal. We're testing whether it's not 200, so the null hypothesis will be that it is 200. Is not 200, that's the one that just goes not equal, so we're testing the one not equal. So this would be a two-tailed test. We do not reject the null hypothesis, so our conclusion would go there is not sufficient evidence. There's not sufficient evidence to conclude that the mean number of peanuts is not 200. So it's kind of a double negative, but there's not sufficient evidence to conclude that the mean number of peanuts is not 200. And it will go like that. And then we will get into this idea of type 1 and type 2 errors and just describe these briefly in the next video, and then we will see a full-blown example of testing a hypothesis.